Hey, g'day everyone, Mr. Jones here for another lesson. Today our objective for the lesson is we are going to be converting improper fractions to mixed numbers. That's going to be our goal for the lesson. I'm just going to move myself out of the way down here to the corner if I can. How we're going to do that, steps to success, we're going to convert to change from one form to another. In this case it's going to be converting improper fractions to mixed numbers. And we need to know that a mixed number is a whole number and a fraction. First of all, let's look at improper fractions. A fraction in which the numerator is greater than the denominator. Here we have an example. We've got two whole numbers that have been broken into four parts. 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 parts in total. Every whole number is broken into 4 parts, so my improper fraction should be 8/4. Let's have a look at another example. Here I have two whole numbers, okay, or two shapes. The first whole number, both of these numbers have been broken into 1, 2, 3, 4 parts. How many parts do I have in total? 1, 2, 3, 4 parts. 5, 6, 7 parts. How many parts have each been split into? They've been split into 4, so my improper fraction should be 7/4. Another example, once again looking at improper fractions. How many parts do I have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many parts has each whole been split into? They've been split into 2. So my improper fraction should be 11 halves, or 11/2. Brings us to mixed numbers. And that's our major focus. A mixed number has a part that is a whole and a part that is a fraction. They're a bit mixed up. Let's have a look at the example that I've got here. Alright, I've got one hole that is completely shaded. Alright, so I've got one hole. I've got 3 in this one that are shaded. So I ask myself, how many whole numbers have I got? I've got 1. How many have I got left over? 3. How many is each hole broken up into? 4. So my mixed number should be 1 and 3/4. Perfect. Let's have a look at this mixed number. How many whole numbers have I got that have been fully shaded? 1, 2, 3, 3 in total. How many leftover parts have I got? 1. How many is each of these holes broken into? 2. So my mixed number should be 3, 1, 2, 3, and 1, 2. Or 1/2. Perfect. Another example. How many whole numbers are there? Fully shaded. 1, 2, 2. How many parts have I got left? 2. How many is each hole broken into? 3. Answer, 1, 2, and 2/3. Can we change this improper fraction? Alright, I've got 4/3. How many whole numbers have I got that have been fully shaded in? 1. How many have I got left over? 1. How many has each hole been broken into? Thirds. 1 and 1/3. And let's look at one more. How many whole numbers have I got fully shaded in? 1, 2. How many have I got left over? 1. How many is each hole broken into? It's broken into halves, or 2. Answer should be 2 and 1/2. Let's have a look at another one here. This time as part of what I want you to put into your flip book, is I want you to draw a diagram that would represent this. So how many parts have I got? Well, how many whole numbers am I going to have? Ask yourself. All right. How many left over am I going to have? How many parts is a whole broken into? So my prediction is that you're going to have 2 and 1/3. But I want to see a diagram that can show me that. Likewise with this one, I'd like you to draw a diagram that represents 10/5. Homework questions for the week. You need to convert these improper fractions into mixed numbers. Now, I do not care whether you do that using a diagram that we've showed today or using a number line. All right, but there must be some evidence of either a diagram or a number line used to represent these numbers as mixed numbers. All right, we're at the 6-minute mark, so I don't want to hold you too much longer. Interesting concept. Looking forward to seeing how we go. I'll speak to you about it tomorrow. All the best.